Hello friends, welcome to our channel Exploring Things Around and our course Learn C Programming A to Z. So before we start with our today's sessions, if you have not yet subscribed to our channel, I'll request you to please subscribe to this channel so that you can get regular updates on our uploads. So in our last sessions, we learned about array, what it is and what are its usage, how do we initialize it and how do we assign values to our elements and how do we retrieve it. We learned about dimensionality of arrays. We created programs also around it to store marks of different students in different subjects. So we implemented two-dimensional array also in our C programs. So today we'll learn more about arrays. We'll see how array and pointers work together and how the values are actually stored in the memory, and we'll see how can we pass the array values to functions. So far we have learned about passing the primary data type values to functions. We'll see here how can we pass the arrays itself to a function. So just to summarize, if array is collection of similar data type values, and we define it by putting the primary by putting the data type of primary element. Like for example, if it is storing the all integer values, it is collection of integer values, then we say it is int array, int array of integers. If it stores character values, so it is array of character. We learned about syntax related to assignments and initialization. So before we start in our today's course, today's program, uh, I would like to put few bullet points before we get into the programming. So we know an array can store multiple elements of similar type. This thing we learned. We also saw in the program. Another point about array is it does not check the subscript we provide. So for example, if we have defined an array of length 5 and we are trying to access sixth or seventh element of that array, for example, compiler will not throw any error. So this is said as compiler does not perform bounce check. This is what we say, bounce check. So compiler will not look for if you are exceeding the size of that array. It will not give you an error. It will not give you any error. You have to take care of that manually. So whenever you are trying to retrieve the value from an array, make sure you are passing the index, passing the subscript which is within the range of that array, because you will not get any error from the compiler side. Next thing is array variables name. When you define, for example, mark 10, saying that that array variable can store marks of a single student in 10 different subjects. There, the variable name mark, which you say, that is basically the memory location, basically the address of the first element of the array, or what you can say, zeroth index element of that array. In case of it is one dimensional, then it is zeroth array. If it is two dimensional, then it is the zeroth element of the one dimensional array. You understand, right? Two dimensional array is collection of one dimensional array. Similarly, three dimensional array is collection of two dimensional arrays. Okay, so the variable name which you are using for array, that basically stores the address, starting address of that array. So we'll see, I'll show you that also in demo how basically it works. And another thing is array elements are stored in contiguous memory location. Okay, so when you define an array of size 10, for example, so each of these values will get stored in memory in contiguous location. So for example, if the first value of that array gets stored in location 10, next element will get stored in the contiguous manner. So I'll show you what this contiguous basically means. It is not the continuous manner. Like if the first element is stored in location 10, it does not mean next will be stored on that 11. It can be 12, it can be 14. So that depends upon the data type of that element. So I'll show you exactly on in demo how those locations are identified. And since we are saying the Variable name stores the location of the first element. So using that variable name, you can use the pointers concept and you can retrieve the values from the next locations also using the pointer rather than using the indices, rather than using the subscript or index of that array. So let's get into programming. I'll show you that in demo. So this was the program which we created in our last session. We created this program to store marks of three students in five different subjects. So this was the program we created. So first thing I would like to show here. So let me comment all these things and we'll create a new program. Okay, so let me do one thing. Let's create a new program. Let that old one be open. So I'll say hash include studio dot h, okay, and void main, and I am defining a array of integer array of three element and assigning values also at the same time. Let's say 2, 7 and 10. Okay, I am creating a character, an array of character type, let's say ch, and I am of 4 length. Okay, and let's assign some values to this. Let's say x, z, y, b. I'm just putting some random values, no logic involved there. And I'm creating another array of type float. Okay, and let's say fl, and this of, let's say size 3 only. Okay, so I'll show you how all these values are stored in memory and how is involved here. And let's say it stores value 1.4, 4.2, and let's say 3.1. And one more thing, since it is character, right, so let's put all these in single quote. So what we did here, we declared array variables, and at the same time we assigned values also. So one thing first I'll show you the address of first element of the array. Okay, and the name of the array variable, both are same. So let's print the address of first. When I say first element, basically the element at zeroth index. So we learned about that here. Index starts from the zero. So let's do one thing. Let's follow the same convention. Rather than saying first element, we'll say the zeroth element. Since we know, right, the compiler will take zeroth as the first element. So let's not get confused here. So we'll say zeroth element only. Okay. So the address of zeroth element element of a. Okay, so we know we can use ampersand operator, right? Ampersand operator to get the address. So and the index 0, so this will give us the address of the first variable, right? And let me print the value of variable name a. So if you directly print a, okay, and if you print address of 0th element of a, let's see what do we get in output. So I am saying here address of 0th element, which is ampersand a0, and next is value of a. So let's run it. I'll save it as array part 2 and source file as c source file. Okay, let's compile it, and okay, some error. Okay, we missed a semicolon here. Let's compile it again. Hold on, did I miss anything else? Okay, okay. This is float, right? There was typo. Okay, so now no error, no warning. Let's run it. So what we learned earlier, the name of variable stores the address of 0th element of that array. So we should be getting the same result from the both print statement from the print function. So if you see here, address of 0th element, okay. Oh, hold on, I missed to assign percentage d here. Hmm, that's why I didn't get my. Let's compile and run it again. Hmm. So in place of percentage d, we could have used percentage u also. We use that for unsigned number. We know memory location are not signed integer; those are unsigned integer. So we could have used percentage u also. So now we have the output. If you see here, address of 0th element, which is 2293312, and the value which is in variable a, that is also 2293312. So you can understand here basically the variable name is nothing but a pointer. Okay, this variable name stores the value address of 0th element. So we know from our pointers concept, we can access the value by using star operator, right? So let's print the value which is stored at A. So if you use star A, ideally what you should get, since A is the address of variable A, array A, 0 element, so we should get the value at 0th element, which is 2. So let's print here value at A is. So let's see that in output. I'll compile and run. So you should be getting 2 here. You see, right? Value at A is 2. Why? Because A is having the address of 0th element of that array A, and using star operator we can get the value at that address. So you don't need to explicitly define a pointer variable to access the address of the array. By referring to the array name itself, you can access the address. Okay, so let me comment out all this and I'll show you about the bound check. So if I need to print the at value of a third element, for example, sorry, so it is of size 3 only, right? And we're starting from 0 element. So let's say we are printing value of element 2 and value of element 1, and while programming by mistake I wrote here rather than 2, I wrote here 12. Okay, since array A is of length 3 only, so we are expecting it to store only 3 elements value. But while writing our program, if we used by mistake 12 here and compile it, okay, you see you will not get any error or any warning related to this part. You have to take care of it by yourself. Compiler will not help you there. You have to be careful while using the index. And let's run it also. Okay, so when you run, One second. So let me change here. I have written 0 there. So this is for second element. Okay. And let's say slash n. This is for the first element. Okay. And let's say here this is 12th element we are printing, right? So we know that there is no 12th element in the array, but still we are trying to retrieve it. So we'll compile and run it. So you can see here the address of second element is 10, which we got that correct value. Address, sorry, we are typing here address. Basically, this is the value. Okay, value of first element is 7, and last value of 12th element. Here we should have written value. Okay, so just ignore that for now. Okay, the main focus is on the getting the value at that index. Okay, so I'm typing here, but you can see here you are not getting any error related to this. You are exceeding the limit of that array, you are exceeding the bounds of that array, but still you are not getting any error when you are trying to access the value of any element out of that array range. So this is why we say it does not perform any bound check. So we learned about this. Now let's go back to our memory address location of the array elements. Okay, and I'll show you what the contiguous means when I said there. So let's try to print the address of each of the array elements. Okay, so I'll say here address of integer array A. Okay, we can use loop, right? So we know this, it is of 3 element. Let's create a counter variable, say I, and let's use that variable. So for I equal to 0 and I less than 3, I plus plus will print address of, here we can say ith element, and we'll map here I comma the slash n. So this one we are printing for integer array. Okay, integer array address, or let's say integer array memory map. So we'll see what are the memory location assigned to this array element, to these array elements. And let's use same for others, for character and for float. So I'll change here from integer to char. Okay, here also I'll say char. For char we have 4 elements, so I'll change the counter here I less than 4, and here name will change, it will become ch, and here also it will become ch. Then we'll change for the float also. Here we'll say float. For float we have 3 elements, so this is fine. And here variable name is fl, and let's say here also fl. And here in place of 0 we'll use the counter I. Here also we'll do that same, and for float also. Okay, so what we are doing here, we are printing the address of each array element. So this loop is to print address of array elements of int A. Second one is to print the address of array elements of ch array, and third is this loop is to print the addresses of array elements of fl. So let's run it. Let's use slash n just to be careful that these lines don't get merged at the same line. Output don't get merged on the same line. So let's compile and run. So while it is running, let's recap few points. For integer variable, we know it can store data of length 4 byte, right? Char, char we know it can store of data of 1 byte. Sorry, integer is of 2 byte, and 4 we float we know it can store data up to 4 byte, right? So let's see here. Okay, and another thing, these all are compiler specific. You cannot be sure it by theory. Safe way is always to check it in your program in the specification for that compiler you are using. So let's see here the output. So if you say address of 0th element, see the last digits. First element is at 12th, second is at 16th, third is on the 20. So you can see the gap of 4 byte here. If you refer to the for character array, you'll see here 96, 97, 98, 99. All are the having difference of 1 byte. If you refer to the third one, float array, you will see here 80, 84, 88, difference of 4 byte. So one thing we can observe here, all these locations are, this is what we call contiguous locations. And here in this case, integer is also having 4 byte memory location range. So if you want to verify it, we can with the help of Sizeof operator. There is one operator in JT called Sizeof. So this one you can use to get the size of any integer variable. So let me show you that. So what we'll do, we'll call printf function, and let's say here let's check size of our integer element, size of integer variable. Let's say here percentage %d, and here what we'll do, let's use size of function, size of operator, and we can pass any integer variable. So for the sake of that, we can pass even I also. This is our integer variable, so this will also give the range size of that variable. So let's compile and execute it again. So this should confirm that for def C++, integer is having 4 byte size. Yeah, you see here, right? Integer of size of integer variable 4. It returns value in byte, so it is a 4 byte. Similarly, if you want to verify it for char and for float also, you can simply create char variable and float variable. Let's ch1, let's say that one, and here say let's fl1. If you want to verify it for double variable also, you can define one double variable, and same function you can use to get the size of these variables. Let's say here ch1, and here I'll map size of ch1. Similarly, here you can say fl1, and let's map here size of fl1, and here let's say double, and let's map db variable. So this will give you the size of each of these type variables in byte. Okay, we missed to use slash in here, so you'll get all the outputs of those four line in single line. So you see here, size of variable integer 4, size of CS variable 1, size of FL variable 4, size of double variable 8. So these all are in byte. Okay, so this is returning you integer variable size 4 byte. This is 1 byte. Okay, this is also float is also 4 byte, and double is to store data up to 8 byte. So these bytes are helpful when you need to store data of some higher range of higher value and you are not able to accommodate that in the given data type. For example, if you are not able to store data in 4 byte float data type variable, you can go for the 8 byte double data type. Similarly, there are few keywords related to size modifier like short, long. These also you can use to maximize or minimize the size of these data type variables. So I hope you understood about the meaning of contiguous. So the memory locations assigned to these variables will be in contiguous fashion. So if it is integer array, so you'll find the difference of each element's location having the difference of that particular data types byte size in byte. So for example, if it is integer, you can notice the difference of 4 byte in each memory location. Similarly, for character, you can notice difference of 1, and for float, you can notice the difference of 4 byte again. So let me show you with the help of pointer how can you access the each element of these variables. So let us consider for now integer variable, and we are trying to access the each element. Rather than using indices, we'll use pointer this time. Okay, so we'll use for loop again. I is equal to 0 and I less than 3, since we have 3 element, and here we'll say value of ith element of A is percentage D, and here I'll say I, and here what we'll say, we learned about pointer, right? So pointer I, pointer A, this will return you the value at zeroth location, zeroth element. If you need to get the value at next location, okay, you can add that to pointer variable. So let me show you here. So I'll increment the address of variable A stored in variable A by the I. So let's compile and run it here, and we'll see the output. So one more thing to observe here is, here when you add value of I, which will start from 0, 1, and it will go to 2. Okay, so let's say I, it will have 0, then I, it will become 1, then I, it will become 3, 2 in these 3 iterations, right? So when you add this value with variable A, and we know variable A is nothing but address of 0th element. So this is very important point here to note. So let's say if it is 120012, okay, let's say the location is, for example, 120014, for example, and when you add this variable a plus 0, this is what we are doing here to get the next memory location. So since array elements are stored in contiguous fashion, we can increment it, we can increment the location by the difference of variable size, and we can get the starting location of the next element, So that's what we are trying to do here. But when you add just 0, 1 or 2 to a memory location, it is not basically normal arithmetic operation. What I mean to say here, when you add 1 here, for example, it will not be 1 0 1 2 0 0 1 5. It will be depending upon the it will depend upon the data type of that array. For example, if it is integer, this will get incremented by 4. Okay, here also it will get incremented here by, so 2 into 4, the size of that variable. It won't be direct increment of that variable. So if it would have been character variable or double variable, it would have been incremented the size of the data type, for example character, so it would have been 1 into 1 or 2, and similarly for double it would have been multiplied by the 4. Okay, so here when you add, you will get the actual memory location, so it will be 120014. Here you will get 120018, and here you will get 120022. So this is how you will get the location of array elements. And using the pointer operator, that using the pointer operator, you can access the uh, element value of element at that location. So this is a very important point. When you increment an location and address variable, it won't be a direct increment by that value. It will be the increment multiplied by the size of the variable, and that will get added to the location. If it would have been variable integer, say int x is equal to 10, for example, and you have added I to this one, it would be normal arithmetic operation. But pointers behave in a different way. Similarly, if you use minus, okay, a minus I, for example, that will also work in a similar fashion. So pointers have some limitations. Okay, address variables, for example, they have some limitation. You cannot perform multiplication or division on these variables. You can perform only addition and subtraction, and that too in the given fashion. When you add some value to that, that will get multiplied. First, that value will get multiplied by the size of the variable, then that will get added to the location. It won't be a direct arithmetic operation. Okay, so let's go back to our presentation. So we learned about the bound check, and we learned about the addresses stored in the variable name and how we can access the array elements with the help of pointer, and we also saw the memory map of these array elements. We also learned about the arithmetic operations available on pointers and their limitations. So I hope you like this video. If you have any doubt related to the demo program or related to array or pointer, feel free to put that in comment box. Thank you. Thanks for watching. Don't forget to share it with your friends and subscribe to our channel. Thank you.